Hello, this is our project for the microprocessor course. Our project is energy saving classroom. Now I'm going to explain the components and their activities. We have used Arduino Uno as the microprocessor as the project does not require much memory. We have used a breadboard to manage all the connections, and we have used also jumper wires and other wiring components to connect every component. We have used a motor controller to control the output to the fan and other components. We have used two lithium-ion 3.7 volt lithium-ion batteries as power source. We have used two IR sensors to detect the input to the classroom, and we have used LEDs and a propeller fan to show the output generated by the project. Now we are going to demonstrate the project. The classroom can be divided into three major parts. The input section which consists of the IR modules that will detect people coming in or out of the classroom. Then there is a microprocessor which will manage the input or output. It will increment the counter if the entry infrared is triggered and decrement the counter when the exit infrared is triggered. Finally, we have our output section that consists of propeller fan, LEDs, and motor controller module. The motor controller module will control the fan speed, and the LEDs will be controlled via software to implement the amount of output.
We are going to show you how our classroom works. Every blockage will be count as a person. Person 1 going in, person 2 going in, person 3 going in, person 4 going in. Now it's time for exit. Person 1 going out, person 2 going out, person 3 going out, and finally person 4 goes out, and the classroom and the classroom's electricity turned off.
Hello, so now I'm going to explain the code segment of the project. After the system has been implemented, the system will check if every component is working properly, and if any of the component is not functioning properly, it will just end the process and send an error report. And if everything is working properly, then it will take input from the infrared. If it detects an obstacle in front of the entry infrared, it will increase the count. If not, it will just pass the option by and check for input from the exit infrared. And if it finds an obstacle in front of the exit infrared, it will decrease the counter, and if not, it will just simply read the count. And if the count is less than 0, it will set the count to 0 so that we don't reach negative numbers which might hamper the process further. And it will just turn off all the appliances. And if the count is greater than 0, it will check set limit. For example, here the set limit is 2, and if the count is greater than 2, it will turn everything on, all the appliances on. If not, it will turn on half the appliances. So this is how we can control the outputs, and finally after each output is reached, the system will reset itself and check the system again.